Okay, now the end-to-end tour of the cloud platform. So Mandy and I were talking, we thought it'd be good to give you an idea of what it's like to build an app on the cloud platform. And in order to do that, we wanted to build a meme generator. Does anybody know what a meme is? So this is kind of the Webster definition of a meme, but of course you and I know the meme on the internet is more like one of these. So a picture with some text that's hopefully a little bit funny that kind of conveys an idea or whatnot. Or this one, I don't know who that guy is. Okay, so we want to build a meme generator. And so the basic idea is an App Engine app that lets you choose from a set of templates, add some text to it, and then create, and then you can browse those memes on the web. So we're going to build out that app, and given the announcement, we've got just enough time to get that going. So we're ready to start building that app.
We need to store these images in the cloud, right?
You want to store them?
Store them in the cloud.
In the cloud as well. So so we may have enough time to add in a back end and store the actual resulting memes into cloud storage. So we can show you how to interact from App Engine to store into cloud storage. Okay, so we should really get started now, though, if we're going to have enough time to finish this.
Brad, sorry, but we need to be able to store some metadata for the images so that we can search them, so we can browse them. So
you want to store the metadata?
I want to store some metadata, yeah.
So where do you want to store this metadata?
I think we should store it in a popular NoSQL database.
What NoSQL database do you use? Mongo.
Mongo.
Okay, fine. I guess we'll store it in MongoDB. So what we'll do is we'll store it in MongoDB. We'll spin up a MongoDB cluster on Compute Engine and show using an open source package on Compute Engine to store that. Now, of course, you could use Cloud Data Store, perfectly fine solution, but you may already have experience with MongoDB, already have developers and skills, expertise in that, so we want to show you how to go do that. Okay, but if we're going to do those, we should just really get going.
Wait, you said a web application, right?
Yeah, web app.
How many guys are using the web here? I mean, you want to use browsers, right? You want to use, your mobile devices, your tablets, your phones, not just a browser.
You want to build a mobile app?
I think we want to build a mobile app.
Okay, she wants to build a mobile app. Okay, so what we'll do is, are you sure about this?
I think we should.
Okay, so what we'll do is we will add a set of cloud endpoints to it, and then we'll consume those in an Android app, so you can get the full experience. I'm telling you, we better roll now, though, if we're going to get this done. So what we'll end up with is an app that looks something like this. Very simple Android app, lets you browse the set of memes that are already stored on the server, and then lets you go and post a new meme. Okay, so the very first step, as we mentioned earlier, Mandy cleaned her machine. She may have got the SDK installed already, but we're going to show you how to create a brand new project, set up her workstation, and deploy at least the skeleton of an app. So let's start with that.
Okay, so can you switch to the, there you go, right, okay. So the first thing we're going to do is go to cloud.google.com/appengine. And this is a fairly new feature on the cloud.google.com website. It's for App Engine specifically, and it has a big Try It Now button, which is pretty cool. Make it bigger. Click on Try It Now, and that will take you to a bunch of useful resources, effectively a recipe for getting started with App Engine. So how many of you are developing on App Engine today? Not today, I'm just generally.
All right.
Not right now, of course. So basically, this, for those of you who are not developing on App Engine, this is a really great way to get started. It has a bunch of steps, I think 6 in total, and it walks you through getting started. The first thing you need to do is create a cloud project, and you have to provide a name. So
yeah, use your creative freedom, whatever name you show them. Your
I could spend ages
inspiration.
trying to work out names. I'm going to call it Cloud Meme Backend, because that sounds really unique.
That's exciting.
Inspirational. Right, okay, so you're inspired now by my project name. Okay, so what about language? We need to choose a language. Because
I think
App Engine supports 4 languages currently.
Yeah. So I think we should do Java. Java, popular language. Everybody uses Java. Yeah.
Java,
Python.
I'd personally.
Python. The whole white space thing with Python drives me crazy. It's white space sensitive.
I think consensus probably suggests that we should use Python. So
Python. And you're driving the demo.
I'm driving the demo as well.
Probably do.
So maybe the code that we have is already written in Python.
That could be the case.
which could be a deciding factor. But once you've selected the language of choice, you get to try some starter code. And Python has some frameworks, it supports web frameworks, Flask, Django, Bottle. You can choose. I'm not going to toggle between them because it takes a little while to load. But you get some sample code with it. You get an app.yaml file. The app.yaml file, as we saw earlier, is the key to deploying App Engine applications. Metadata that describes the application, and some handlers that map URLs to application scripts. And we can go back to the main.py here. We have some code. We can run that code.
Yeah, so this is really cool. This, if you're brand new to the platform, you just want to play around with it, see what it's capable of, what it's about. You can experiment with things. Manny's going to just change that to be something, another creative.
Another inspirational piece of.
And then you can see the change happen immediately. We just have a instance of App Engine that we're able to run all these off of. So that's nice.
Right, okay, so having some sample code, and we can change that code to our heart's content, to be honest. But we can also download the code as well for later use. Or next step is to install the Cloud SDK, which I did remove, so I'm going to have to.
Oh, okay, great. Okay.
So the Cloud SDK, as I mentioned earlier, bundles all of the tools that we've had before for our products, our cloud products, things like GCUtil, appcfg.py, various different tools. And it adds some new tools as well, one called gcloud, which gives us the ability to do authentication, configuration and setup and such like, and also to access Git push to deploy repositories, which we're going to look at later. So I'm going to install it. We have options for Mac OS X and Linux, and we have Windows. I think I'm running on Mac OS X. I think I am. I'm kind of so confused.
How many people develop on Mac OS or Linux? Mac OS or Linux. Okay, and then Windows? Okay, about a quarter. Anything else? Okay, good. Chrome OS? We'll show you a little piece of a Chrome OS story.
So I'm now running this installer. It's basically we're curling down a very simple script in Python. It's a bash. It will download some other stuff as well for us in the background. Ask us some questions. Where do we want to install it? And do we want to...
You absolutely want to improve the SDK. This basically does Google Analytics for us and helps us know what commands are popular, what people are using, all anonymous.
And the next thing we have to do is choose which language we're going to develop in on App Engine. If you're not developing on App Engine at this particular point, you may select the option number 4 and not install anything. You'll still get all of the tools for the other products, such as BigQuery, Compute Engine, cloud storage. In this case, we've chosen Python, so we need to select option number 2.
But as we'll show you in a minute, these are all mix and match. You can come back, you can add as many as you want, you can delete them later, as we'll show you.
And just quickly going back, because that takes a little bit of time to run, we see some example usage of the gcloud command, which we're going to run ourselves shortly. Then we have examples of using the local development environment. This allows you to run your code, your App Engine code, locally on your own machines to iteratively develop and test your application. And it gives you exactly the command line you would run for the sample code that you created earlier. And you could access that code running on your local machine at localhost 8080. And the final step is to create your project. And big red button here would create your cloud project for you and ultimately deploy your code for you. We're not going to do that. We have a pre-configured project, which we're going to use for this particular demo. So going back to the SDK install, going to move that screen up a little bit. Next thing is to configure the environment. We have to provide a run command file. Well, it's optional, but provide a run command file to install some configuration. And then do we want to modify our path, update our path to contain the tools? Yes. Do we want to enable bash completion? Yes. So that's it, that's done. We've installed the SDK many times on this machine, so it didn't really do much there. At this point, you would source your run command file, in this case, and that would put all of the tools on your command line. So now we have access to the gcloud command. So
not really sure what the commands are for gcloud, because many of you are very new. So luckily, tab completion can help. So Mandy just hit tab there, and that shows the list of commands we have today. Pretty much every time you go back to it, you're going to find new commands. We're actively developing the unified command line tool.
Hopefully, you won't find commands going away.
No. These are good. These are going to stay, yeah.
So we're going to use components, yeah? So
yes. So why don't you do components, and then tab completion on that, of course. Hopefully makes you more productive on the command line.
So the option to list, we'll use that one,
yeah? Yep.
So G-Cloud components list.
So this is what we have installed on this machine already, what came by default when she said Python. You can go see if there's any updates, add and remove new components as you see fit for your development.
Make that wider so you can see everything that's installed and everything that's not installed. And the next step is to perform authentication. And one of the great things about G-Cloud is that it's infinitely possible to spell it incorrectly. I want to clear that. Right, so the first thing we need to do is authenticate.
Yes.
So
yeah. So you're just going to do a G-Cloud auth, right?
Yeah.
So basically, what we need to do is make sure that SDK locally on her machine can connect up and access cloud resources.
Exactly. So G-Cloud auth login will authenticate for us. And what it will do is we'll open up a browser. If you're using multiple sign-in in Chrome, make sure it's the right browser because it might do this for the wrong user. You can cut and paste the URL into a different window. But in this case, it's the right one. It's my corporate account, which we're using for this. And basically, Cloud SDK is asking you to accept permission to give it rights to access these services on your behalf. And it's got a long list of services. And we're going to click accept on that. And that's done. That's finished.
And so notice there's nothing else you have to do. You just go there, click accept, and then we do some magic cookie exchange and do the OAuth token dance behind the covers, and you're all set up now.
And you do have the option to enter a cloud project ID here. So if you're working exclusively with one cloud project, you can enter that here, and you won't have to worry about typing it in again. Otherwise, you can switch very easily between cloud projects using the G-Cloud command. I'm just going to hit return here.
Okay, so now we have the basic tools installed. What we need to do now is get started writing some code. And in order to do that, we're going to initialize her local workspace. And so that is another command, another G-Cloud command, G-Cloud init, and then passing the project ID. And what that's going to do is initialize so that every command within this directory structure now is going to be relative to this project, to the project with that ID, Roadshow 2014 with that ID. And we've also set up a Git repository, a local Git repository, because we're going to do proper software engineering here and do version control, and we'll talk a little bit, or we'll talk about it now. We actually offer, this is the cloud project, and we offer a free private Git repository that you can use for your cloud development. That's the URL for it. You can hit that from any Git repository. You can do branching, you can do pulls, you can do whatever you want to with it. Or if you happen to be a GitHub fan, how many people use GitHub? Great, so you can just click on the GitHub button and connect to your GitHub repository, and everything else works just exactly the same.
Right, okay, so now
Are we initialized now?
initialize. I'll cd into the directory, and we can do an ls-l. Oops.
Nothing up your sleeve here. This is empty.
And that's our repository. You can sell it to Git repository, which has a .git directory and a .git.
So we're basically ready to start now, ready to start writing some code. And as if you recall the architecture diagram, what we need to do is add 3 cloud endpoint methods. We need to add one to list the templates, one to add a new meme, and one to list all the memes. So I think we might have some code here, Julia Child style, that we can bring in just to save you the pain of having to watch us type.
Yeah, so how many people can not see that, not read that? I mean, I don't think it's too important that you see the file names, but we're at quite a high resolution here. We can change the font sizes in the other windows, but these windows it's a bit harder to do. I can zoom in on those, but I'm not sure if it's absolutely necessary. So yeah, so we have all of these files that we created earlier, and we're going to copy some over, make that window a little bit bigger. The first one is an API method, so very similar to what Lawrence created. Where's Lawrence? Ah, he's over there. So very similar to what Lawrence created in his Android demo earlier. This will be an API. An API that we can expose to clients, mobile clients specifically in this case, because we want to build a mobile application. And we're going to copy that over to our repository. And then we're going to look at it. So now we have it available to us. We can have a quick look at it and see what it contains. So I'm not going to spend too much time on this, but we do have some markers, some comments here for some code we're going to add later. And the key thing about this is that we're just exposing the API at this stage. we don't really have a huge amount of functionality. It's all stubbed out. We have some stub memes, very simple stub memes that we can use with the application, but it's not going to be dynamic at this particular stage. Stored memes, here's our collection of stored memes. It's a meme collection, and it has, you probably want to make note of the text. Good guy ERS uses actual numbers. That's what we will see when we look at the application. When we define our endpoints API, that's a Python class, Cloud Meme API, which is annotated with @endpoints.api. It's different from Java for some reason, but effectively what we're telling the endpoints runtime here is that this will represent our API for us. The endpoints runtime can do a lot of inference. It can infer things about the name and the path, and we've left some of that, but we have provided a name, Cloud Meme in this case, and we've also provided a version number, in this case version 1. And the implication there is that you can have multiple versions of your API running. And then allow client IDs are effectively who can access this application. And these are going to be client IDs from our mobile app and a scope as well. And then we can quickly look at the methods that we expose.
The interesting thing with those client IDs is that it's basically we're doing a crypto key exchange between the signed Android app and the service. So we make sure only our signed Android app can access our service. So if you tried to hit the service without coming from one of those apps, then you can't access it.
So our first method is memes create. We want to be able to create memes, and this is annotated with endpoints.method. And here we're telling it the path of the API, and this is a HTTP post request, and the name of the API call is memes.create. And interestingly, here we have current user. So current user allows us to get the current user from endpoints. Then we can check to see if the user is actually authenticated. Is this person logged in as a Google user? If they're not, we can actually throw an unauthorized exception and stop them from accessing the API. And we'll see this in action later.
Yeah, so basically we don't want you to be able to post a meme unless you're logged in. So spam is sort of low on our meme service.
In this case, our URL is just a stubbed image. It's just a path to an image that we have already created. Nothing dynamic there. And then we have memes list, which is also annotated, and this is called memes.list. And this returns our memes collection that we saw earlier in the code. Just 2 memes, completely static. The final call is templates_list, and this returns an array or a collection of stored templates. And the templates are effectively just the image that we use for memes. And that's pretty much it.
Okay. So we have the basic endpoints defined, and I think what Manny's going to do now is make this an App Engine app. Or
I'm actually just going to deploy that file.
You're going to add it to your Git repository.
I'm going to actually add it, commit it, but not push it.
Yeah. So good software engineering practice. She's going to commit it to her local Git repository. So we've got one part of the app working, so she's just going to commit it there, so it's checkpointed to her local Git repository. And then the next step we need to do is make this an actual App Engine app. And to turn it from just a Python file to an App Engine app is very easy to do. You just add an app.yaml file, and I think we saw this earlier.
We've looked at this quite a lot.
Yeah, so it's the same basic format. It's a YAML file format. And then I guess from a software engineering perspective, we need to write some tests. So we want to write some unit tests to make sure that the functionality works. And luckily we have a few of those already done. So you want to add those in?
I think so. So how many people here write their production code without unit tests?
Yeah, some people will admit it.
Great. So we'll have some tests. And that's it. So
okay, great. Yeah, so I think Mandy's now going to commit those.
Yep.
So now we have the app and the tests ready to go. We're going to commit to the local Git repository. And then once she's got those in her local Git repository, we will push them up to the cloud. And we'll give a very descriptive error message.
And yes, so now we have to do git push. That's complicated, right?
Yes, that's very easy actually. So when we did the gcloud init, that set up our Git remotes. So if you're really familiar with Git, you know all that Git remote magic. We set it up to point to, and you see that URL is the same URL we saw in the Cloud Console where the Git repository is. So now if we flip back up to the console, actually maybe the first thing we should show is the viewer. Do you want to get on the console? Let's show them the source code viewer in the development tab, source. source?
So, yeah, source. We
I like to mix it up. We practiced something different.
We didn't do this before, did we?
We practiced this, but I thought that London would want to see this.
He wants to keep me on my toes.
Yes. So, and you can see all the source code. What we wrote locally, we pushed it up. Now what we can do is flip back to releases, and you should see in the release history. Oh, it's not quite there yet. Maybe. Okay, so let's switch back to config. It just takes a minute for the release history to work. So go back to configuration for a second. So what we showed you earlier, that repository URL, and now the release type, that tells you what's going to happen after you've done a git push. And you want to drop it down. So what we're showing here is unit tests. We're going to run all your unit tests and then do a deployed app engine. If you had said Java, Maven, or Gradle, we would have built that. And so what happened when Mandy selected that earlier is it spun up a compute engine instance. It installed Jenkins and Python on it. And then when you did that git push, it pulls the code down to the Jenkins VM, does a build, and deploy. So there's the push to deploy image that was spun up on our behalf. And you can see Mandy's been practicing this demo a little bit. That's each time she's done a push.
I don't remember doing that.
Or somebody has been practicing this demo. Okay, cool. So now let's see if we have that happening now. Awesome. Okay, great. So you can see this is the commit that was done. Tests have been run, and it's been deployed. So we should see that in production now.
We should see that in production. So just going to check on something. Commit.
Yeah. So this actually rolls up all the commits that Mandy did in order to make that change happen.
But I want to look at the tests.
Sure. Let's look at the tests.
So the tests, we can dive into the tests, into the no set.
So basically what we've done is taken the test results from the Jenkins machine, and we pulled them out and made them available so you can query them here. Those tests kind of ran very quickly.
Yeah, I know.
Suspicious.
I've been learning from Craig about writing efficient tests. And
efficient tests. Sorry.
He's given me some really good pointers.
Okay, good.
So we want to actually look at the API, right? So
okay, yeah. So now recall what we built was a set of APIs, so we need to use API Explorer to go check those out.
And this one works. I don't have the proxy enabled, so that's good. So we click on Cloud Meme. Remember, it was called Cloud Meme, and it's version 1. This is Cloud Meme API version 1, and there's our 3 methods. Memes.create, memes.list, memes.list_templates. And we can click on list. I think list would be a good one to start with. Click on execute. We've all seen this already a few times now. And there's the memes that we had, the static memes that we had within the API file.
And just one thing to point out here, we'll show you client libraries for all this. You saw that earlier. But as you can see, this is just the REST call. So if you want to use curl to access it, you can. If you want to roll your own libraries, that's perfectly fine. You can see exactly what the inputs and outputs.
Yep.
And as we were working on this demo, it's nice to be able to know what's a client error and what's a server error. So if the client guy comes to you and says, hey, there's a problem with your API, you can go back to API Explorer with exactly those results and show them what it's supposed to be.
Okay, and we can also create a meme. Again, this is not very dynamic, this application, so not a huge amount is going to happen, but we can create one anyway. So in this case, we're just going to pass in a string as an image URL, some URL, and then some text as well. In this case, some text.
Yeah, and as you recall, this is stubbed out, so it's just going to return success and not store this anywhere.
But just to mix things up as well, I'm going to perform authorization. The APIs Explorer allows us to perform authorization and not get an error message. Because normally when we do this, we get an error message, a nice big red one, which we expect to get. But we're going to actually change that now and not get one. So I'm going to click on that, and it allows us to actually authenticate as a effective Google user using the APIs Explorer. And that's now on. And so now we can actually make requests. If you go back to the code we looked at earlier in Sublime Text, this is the create code here, the current user stuff, effectively saying we need to have a validated user to be able to access this method. So going back, we can click execute. That will run. Right. And again, we see all of this interesting stuff that Brad's going to talk about.
Yep. Yeah. So basically, you're getting the bearer token. So if you want to see how the authorization works, you can kind of see that in there.
And that's what our post request looks like. And ultimately, we get a response back to OK that we created a meme. Nothing actually happened here. Our create method isn't fully implemented. So ultimately, we're going to do that later.
Okay, so can we switch back to the slides? We've got the first part of this done. What we showed you, hopefully, is how easy it is to get started. We started talking about how we're embracing these open standard tools like Git and Jenkins. We showed you very simple build and test in the cloud, or at least test in the cloud, no build for Python. And we showed you the API Explorer. So there's a whole talk on this. If you want to grab that title, you can just search for it. It's recorded on YouTube. So the next step we need to talk about is building this client library, the Android app. So we want to build the Android optimized endpoints client library and consume that in Android Studio. And as you call, this is a little bit different from what Lawrence did because we wrote this actually in Python on the server, and I think that just underscores the point that we're abstracting away what's happening on the server from what's happening on the client. So we're going to switch back to the demo machine.
Second bottle of water.
Awesome.
Right, okay, so the first thing we need to do is build a client library.
We need a client library.
Okay.
So, in the old style, what you might have to do now is spend a bunch of time defining all the POJOs, all the entity objects on the client, doing the networking calls that are in the right threads, in the background thread so it doesn't break the UI, doing all the authentication and whatnot. But we can just call this endpoints config.sh, and it will generate a strongly typed client library for us. And in our case, we want that in Java.
Sorry, I'm just checking to make sure. Making sure I get the class name right.
Yeah, we want that in Java, and we want to use a particular Java build system. We want to go ahead and use Maven, because that will help us work well with Android Studio. And what that's going to do is take the endpoints description that we had. There's actually a XML-based description format of those endpoint that she just created. And then there's a service that takes them and turns them into various languages. So you may be interested in Objective-C, or somebody was asking earlier about C#. We have generators that can take those in a variety of different formats and create the right language for you for exactly what you need. Yeah. So we're going to generate it in Maven, and then when that's done, Mandy's going to copy it out and open it up, and we can see exactly what that generated.
So as you can see, it's called Cloud Meme, which is the name of our API, -v1, which is a version of our API. I'm going to move it out of the repository. We don't want to end up checking it in and running tests against it, particularly not my tests, because my tests would probably complain.
Yes.
So we'll move that to my home directory, and then we'll unzip the newly created Cloud Endpoints Client Library, and then we have lots of files there. So as you can see, these are all the files that were generated. Some of these are resources. The resources we use for the APIs, things like the model Cloud Meme represents a meme within the Cloud Meme API, and also things like the actual methods that will be exposed to clients. And we can look at this file, which is called cloudmeme.java. And here it is. It's pretty straightforward. This is the kind of thing that you would effectively pass to your client. Your client would write his code to this class file, and ultimately all of these calls, the API calls that we had earlier, will be stubbed out. But underneath the hood, the underlying runtime would send the messages to the API endpoint. So here we have the root URL for our API, which is something we just typed in earlier. Cloud Meme /v1 is our API itself, and we can create a default base URL from those two paths. And further down, we have the definition of the API itself. We have a resource, a memes resource. And we have create, the create method. This effectively creates memes.create. And then further down, we have memes.list, the list method, which will be called by clients. And finally, the list templates method, memes.listTemplate, which will allow us to access meme templates. That's it.
Yep. Yeah, so basically in the code that was generated, we have the entity objects, we have this class that you can call when you're writing your Android code, and then all the plumbing code to do serialization and deserialization between those JSON objects, handle all the authentication. So now what we want to do, you notice there was a POM file generated there, so if you're a Maven person, you'll recognize that as the build format. So what we're going to do is just run Maven install on that, and that will build this client library for us, and it will install the resulting jar into our local Maven repository. And that will make it easy for us to consume that from Android Studio. And amazingly, it built. That's a good sign.
So we've done this a couple of times on this laptop already. So all of the dependencies, all of the other dependencies were already installed. I'm always interested to check to see if anything has been updated. And I'm also checking to see if the version number has revved to like 1.19 perhaps. But
yes.
In this case, we have the library now installed into Maven, into our local repository.
Okay, so now what we want to do is open up Android Studio and start consuming this library. And luckily, ahead of time, we've created a lot of the plumbing work for a meme generation thing. We don't have to, you have to watch us write that code. And we're just going to focus on using the client library we just showed. So the first thing we need to do, as Lauren showed, is go into the Gradle file and add a reference to the library that's in the Maven repository. So Gradle is the build language that Android Studio uses. Luckily, it speaks to Maven repos as well, so that's kind of nice.
And here we say, in this case, we have to actually tell Android Studio to use Maven Local, the local repository, and also Maven Central to pull dependencies down. And further on, the great thing about Android Studio is that if you highlight code before you close it, when you open it up again, the code will still be highlighted, which is quite amazing.
It's pretty cool.
But it does kind of ruin demos because it means when you start it up again, everything's still highlighted. But what we're here going to highlight is the addition of a dependency, which was the library that we just pushed into the local Maven repository. So this is effectively the client library being added to the application and available to the application code.
Okay, so we can access the code now, and now you're going to start being able to call that code?
We can indeed. So I'm just going to look at the top-level meme service, and this effectively gives us two actions, create and vote. We're not going to talk much about votes, but we do want to be able to create memes. And here we're using the API here, Cloud Meme, which is a meme for the meme Cloud Meme API. It's just a truncation of the API name and the actual name of the resource. So we can create new Cloud Memes here, and we can perform operations on them, like setting the image URL, setting the text, and then calling the create method. And that's it, really. We're not going to write any Android code. And believe me, you do not want to watch me writing Android code. So we've written all this beforehand, and we can actually show the app running.
Yes. Okay, great.
So we're not going to deploy it.
We already have the app up and going, the Android app. So
can you switch the Android app?
On the device. Yeah, there you go. So now this is hitting those stub services that we showed. And look, there we go. We're seeing the stubbed images. That's pretty good.
And I'm also going to create a new meme. And this is really embarrassing because typing during a demo is really difficult. Actually, I can move the phone around now. So it's quite
yeah, it's a little easier. So
I'm going to choose a different template. So remember, we had a list templates method. We had 6 templates defined, and these are the templates that we had.
So what Mandy's going to show you when she clicks submit here, so go ahead and type it in. And when she clicks submit, what it's going to do is translate that text into Java objects on the client, and then the Java objects get serialized into JSON. The JSON gets serialized over the wire to cloud endpoints, which gets sent to the App Engine app, and then the App Engine app goes and does nothing with them. We'll show what the App Engine app should do in a minute, and then returns the results back, which is still the same stock images.
Yeah, so we haven't really done anything, but we're going to do a lot more, and we'll ultimately come back and revisit that meme.
Okay, so we've got the Android part of this done. So now if we can go back to slides. So we've got the Android part of it done. What we showed you is creating the client library. We used Maven, and we built the mobile client. The next step is an interesting one around handling the storage. So we want to do 2 things for the storage. We want to store the image data in cloud storage. So those resulting memes with the image that's stitched onto them, we'll store that in cloud storage. And then we'll take the metadata and store that in MongoDB so that when we query, we can query for the data out of Mongo.
Right.
Okay,
Good.
so back to the demo machine.
Brilliant. Thank you. Right. Okay. So again, we have some pre-written code, and we're going to copy over cloudmeme underscore image.py and cloudmeme underscore storage.py. The image file here is effectively the rendering stuff, all of the stuff that will render our memes. Take that image, take the text, take a font type, and effectively create the merged image. And the cloud storage code is what we're interested in, specifically, because that's cloud stuff. And this is what that looks like. Effectively, we're getting the cloud storage URL, which is storage.googleapis.com. And then we're creating this upload file method. And that's really pretty much all that this library does, providing an upload file method. And that takes effectively an argument as a bucket and a meme image, an image that we want to store. So the bucket is the cloud storage URL, effectively, the path to the bucket that we're going to use to store this image. And the image is the rendered image. We create the file name, we get the bucket, we add some unique stuff here. We also then add that to the cloud storage URL to create a complete URL. We then do stuff like open a cloud storage file, call it cloud file, we open it for writing. It's going to be type image_image/png. Then we're going to open up the actual data, string.io, and we're going to create that data. Ultimately, we're going to write the file, and then we're going to close the file. Once that's done, we'll return the URL. So effectively, we've created the merged meme, and we've uploaded it to cloud storage.
And so this is the basic code running on App Engine to store a file to cloud storage. And now what we need to go into the API, right, and add calls.
Yep, so now the next thing to do is go to the API file, and I want to open some files that we have here. So like the best prepared developer, we have some files that we created earlier that contain all of our code snippets. And I'm just going to go there. And the first one is cloud storage. So this is the cloud storage stuff that we need to add to our API. It's called cloud storage _code.py. And these are just basically code snippets that we're going to cut and paste into our API file, which is there. So the first thing is imports. We look in the Cloud Meme API, and I mentioned this earlier, that we have these placeholder comments, cloud image build, cloud storage import. And we're going to cut and paste the code from here, which is effectively just some imports and the bucket name, which we've predefined. And we're going to put that into the API file. Ooh, it didn't work, did it? Earlier on. I'm having cut and paste problems, Brad. Right, so try again. So we've imported stuff from the cloudmeme_image library and cloudmeme_storage, define the bucket name. The next thing we need to do is add some code that will actually create a meme for us, and that's this code here. And again, we have handy comments within our code.
Those are very helpful.
Very helpful comments. And we go to create the meme comment and replace that code there. And effectively what we're doing here is creating a new meme. We're passing in an image URL, some text, and the name of a font to use for rendering that text. And the next part is to actually upload the file to cloud storage. And we copy and paste that code there. Go back to our API file, and there's a list gone. Oh, there it is, okay. And we'll replace that file. And before we created the URL from effectively the stubbed image, that single image that we had, now we're going to replace this to make it dynamic. So here we get Cloud Meme Storage, and we create a URL using that upload file method that we saw in the other file.
Okay, so now what we have is a set of endpoints that you can upload. You can send the image, or you can give us a template and text. We'll render that together, make an image, and store that to cloud storage. And then when you do a list, we can actually pull out the right images from that list.
And here's our buckets.
Yep.
It's how many times you've run through this demo already.
Yep.
So we have lots of images we've already created.
Yeah, so this is in the developer console, a handy way for you to just view what's in there. You can manually control it in the UI, inspect it, and make sure the right things are happening.
Yep.
Okay,
Okay.
so that's the first half around getting cloud storage to work. The second half is around getting MongoDB to work. So the first thing we need to do for that is actually spin up a MongoDB cluster.
Yeah, so fortunately for us, we've actually got a very simple MongoDB cluster running.
Okay.
One instance, and that's running as Mongo node. But via the API and via Brad's team, they provided a resource that we'll use Deployment Manager, which we talked about earlier, to actually create for you a complete MongoDB cluster. You can specify the number of instances and machine types, what the arbiter is and such like, and it will create the entire configuration for you. And we're not going to show you that today because the code, we're having a few problems with it, but
Okay.
we do have a MongoDB instance up and running already that will handle our metadata for us. But in order to make that work, we need to add some more code. And so going back to here, we'll open up another snippet file, mongo_code.py. And here we have lots more code, and we're going to cut and paste this into our API file. The first thing is Mongo import. Pretty straightforward. We're going to cut and paste that here, where it says, magically, Mongo import. And basically, we're just importing PyMongo from the MongoDB client. We have a connect string that we created earlier, and this effectively is the IP address of our instance, our node. This could be the arbiter node of a larger MongoDB cluster. Then we're creating a couple of conveniences here. We're creating a client, a connection, and we're going to be using those later in the code. Okay, with us so far? Excellent. And then we need to add some code for creating memes. So when we create a meme, we need to create the metadata, and then we need to store the metadata. So we're going to copy this code, go to cloudmeme_api.py again, scroll down to our create method, and find the Mongo comment here, and replace that. So here we're just basically getting the connection. We're calling self.getMongo, our helper method that will return the connection we created earlier. And then we're creating a meme, URL, text, and the current user. We want to know who created the meme. And also the number of votes, which will be 0 to begin with for any new meme. Then we pull out the collection of memes that we have currently, called db.memes. That will give us the collection of memes that are already stored. And then we do memes.insert to insert the new meme into the collection. And that's all we need to do. The rest of it's taken care of for us. Then finally, we need to do the listing stuff, and I'll cut and paste all the code this time rather than just the top part, and we'll cut and paste that into our list method. And I had this crazy login method that I added really, really on when I started getting up and running with this code, and I've never removed it yet. So here again, we get the DB connection. We create an array of memes, and then we do a query on db.memes to get the memes that are currently stored. We sort them by ID in descending order. And then we iterate across those and we create new memes from them, and we append them to our memes array. And then we return a wrapped version of that array, wrapped as a memes collection. And that's it. That's all we have to do.
All right, cool. So I guess now we need to commit this locally, right?
Yep.
Did you add all the helper files?
Good point.
So while she's doing adding the helper files and committing it locally, just to make sure we're all together on what happened here. So basically what we did is we added the code to store the images into cloud storage and to get those images out of cloud storage. You want to go ahead and do the Git stuff? And we stored the metadata in a MongoDB cluster that's part of our same project. And now we're ready to deploy this up to the cloud and see this thing actually work. So she's just going to add those things locally and then commit them to her local Git repository. And there should be a bunch.
Okay, so we do that. There's all those files.
Yep, and now we're ready just to push those up. Now, when she does this push, what's going to happen is obviously the source code deltas are going to go up and get stored in the Git repository, but also we're going to sync all that code down to the Jenkins instance that's running in Compute Engine. And we're going to run all those unit tests. And if all those pass, we're going to deploy those out into production, update the instance that's already running in production with the brand new code.
Then we're going to talk for a while to Give it a chance.
Give it plenty of time to do that. But so we can probably go back up there and see the diff view.
Yeah, so we didn't look at a diff. We should have done really. We can go back to one of our previous deployments in release history and look at the diff.
We can do the diff here. Yeah. So basically what you saw there is the release history. So all the different pushes that you've done. You can imagine that if you're trying to track down an issue in production, you might need to know like what actual code changes went in. And if there's several people on the project, you might have many different changes into every release. And what we've done is rolled up all the changes for a given release and given you a diff view of that. So you can isolate what happened in this release. So pick some interesting one to show us.
It's still early days. It's still loading some of the stuff.
Okay.
So,
Sarah, you worked on this, didn't you? Where is she? Yes. It's still loading. So Sarah's the engineer that worked. You worked on this, didn't you? Yes. Why is it still loading them? Oh, I see. She's actually doing the diffs right now.
Yeah. So anyway, so the green stuff here is basically new files, files that have just been added as part of this release. And the next one is further down. We can see.
Oh, that's the one. Yeah.
The most important file, the one we care about most, is cloud_meme_api.py, and we can click on that and we can see the diffs. And these are all the changes that we've made recently, and I can just look through them and make sure I haven't made any stupid mistakes. Looks good so far. Yeah, so you can see all the diffs within the user interface.
Okay, so that's pretty cool. Okay, so I think we've given it enough time to run your tests now. Let's see if it's got that into deployment.
I think we're good.
Okay, yeah, so you see it's run test, it's done deployment. We could look at the build and test logs, but those aren't as interesting. We've seen those. You want to just test this in API Explorer. And now the APIs look absolutely identical. You notice we didn't change the shape of the API, so API Explorer will look the same. But when Mandy goes and adds an item, I guess first she's going to...
This list, make sure we don't have any...
Yeah, so there should be nothing there.
We're now dynamic. We don't have anything stored in Mongo.
Templates first, right?
Sorry? Templates, yeah.
Yeah, so she's going to go into templates and grab a URL, because this is going to be real, so we need to actually get one of the template URLs. So she's going to grab that URL, and now we're going to go back to create. And what's going to happen here is when she gets that added and clicks submit, we validate the user. It goes to the App Engine app. It gets deserialized out of JSON back into what did we write this in? Python. Back into Python, and then we store the metadata for that in MongoDB. We knit the image together and store that in the cloud storage, and then return the results back. So,
but in the great tradition of audience participation, we need a meme text from you. So we've chosen one of the URLs, but we need some text from you that we can put to make this very dynamic. So anyone have any suggestions for a text string that we can type here?
Never code on Friday afternoon. That's great.
Never code on Friday afternoon. There's quite a lot of text for a meme, I think, but we'll see. Right, okay, so I think that's done.
All right, so let's go and see if all that happens.
We've done the authentication here. We're creating a meme, so we had to authenticate. Click execute, and let that go off and do its magic. And here we see, again, the post request, and down here, the response, we see that we've created a...
And so, again, lots of stuff happened there. We stitched the image together. We stuck that in cloud storage. We stored the metadata in MongoDB. Just to prove that, do you want to... Oh, yeah, we'll do it from the phone. Yep. So to prove that, we'll go back to the phone. Again, exact same phone app going against the exact same APIs, but now we should see the image that she just loaded about coding in Friday afternoon. Awesome. I love that. Very cool.
And I can go back and create the one that I like.
Okay, yes. So again, now this is impressive. What's happening here? She's going to add a meme here. It's written in Java, so it's a Java object. Serialize that down to JSON. Send the JSON authenticated up to App Engine, where it gets deserialized back into Python objects. Then we go and run the Python image stitching library to stitch the image together. We store that image into cloud storage. We store the metadata in MongoDB. We call list. and we get the results back and display them here. So
there
fantastic.
We are. It's displayed. We can also go back to memes.list and call that again.
You want to go back to the demo machine?
Oh, yeah, sorry, yeah.
OK, there it is. And there it is. OK.
Usually do live demos. And we're done.
All right, fantastic. OK, so we've got the basic app working. Can we get back to slides? We got the basic app working, but we promised to show you some DevOps scenarios. And I don't know about you, but my experience building an app is I don't get it perfect the first time, especially when I get production traffic. And so what we want to do is take a few minutes and show you some very, very simple load testing, throw some simulated load at this thing and see how the cloud platform responds to that. We'll show you there may or may not be an issue in production that we will be able to find. And then once we find that issue, we'll show you how to fix a production issue. OK, so let's get started. So back to the demo machine. So what Mandy's done is she's SSH'd into a GCE instance so that we can get a lot of high bandwidth throughput here. And go ahead.
Also because installing Apache on a Mac it can be a pain, really a real pain. We're going to use Apache Bench. We have that pre-installed for us, and we can run AB -- help to see what options it gives us. And I think the top two are of most interest: number of requests to perform, a number of multiple requests to make. That's not very good syntax, is it? Number of multiple requests to make. OK, never spotted that before. So we're going to run AB. We're going to run AB -n and some order of magnitude of zeros.
Yeah, pick a few zeros here for the number.
But not too many, right? Because we fell foul of that before.
Yes.
And what's our concurrency today? What do
you want to push our luck and do 100, 150? How many do you want to do?
I'm going to go to 250 and see if it...
250?
Okay. See if it upsets me.
So what we're going to... I guess Mandy's feeling confident today. What this is the number where it will spin up on this GCE instance 250 threads, all of them banging on our service at the same time. And they're going to hit this endpoint. There's a special endpoint we added called create that just takes a stock image, adds some text to it, and stores the image in cloud storage and the metadata in MongoDB. And we're going to store quite a few of those because we're going to be doing 250 a second of those. So we have now just started throwing a fair bit of traffic at this site. So if this were your site and you just got on Hacker News, this is your experience and you might be sweating. But because we built this on App Engine, we're not worried because App Engine has noticed the increase in volume. We had one instance going. App Engine's noticed the increase in volume and has started spinning up more instances. Has it already got 16? Mm. Awesome. So it's basically right now it's looking at the rate of increase, and it's saying, well, your rate of increase is pretty big from 1 or 2 requests per second to 250 requests per second. So it's just spinning up instances basically as fast as it can. Once the load levels off, then it will max out at a number of instances that can handle that comfortably. And then when that load finishes, it'll start dropping those instances off.
Right, so let's have a quick look at the instances themselves. Here we are. And yeah, so we have these 20 or so instances running, 20 total. And some of them are doing a lot of things, and some of them are not doing very much at all. Yeah, so
notice some of them are still warming up. Like we get the instance up, get it warm before we start throwing traffic at it.
And one thing I do notice though, Brett,
yes,
that the errors column seems to contain...
We do seem to be having some errors in production there.
That can't be good, right?
Yeah, so why don't we go and look at the logs.
Look at the logs, eh?
So this is the new unified log viewer. We're aggregating all the logs from all those front-end instances in a single unified view. So we're actually doing one entry for every one of those requests that are coming in. Again, 250 a second are coming in. So as she pages through here, and if you look at the timestamp, all this is happening in real time. So they're coming in.
About the timestamp, we can actually change that to be from PDT. It should really default to the local time zone, but for some reason it's not doing so. We can select British summertime here, and we can actually see the log data in the local time.
Awesome.
There's nothing more infuriating, believe me, when looking through logs from a time zone other than the one you're working in and trying to correlate the actual time that happened in the log with the time that's actually happening locally. So did it happen 5 hours ago, or did it happen like 2 hours in the future? It can be quite confusing. So this is very, very useful.
2 hours in the future. Okay,
Sometimes.
so there's a lot of ways you can slice and dice these logs to try to find out what's going on. You can isolate to a given time range. So if you got a customer report of an issue at a time range, you can slice and dice that way. You can do it by log level. You can do it by what module it's on, or you can do a regular expression filter or filter by one of these. I think we were seeing 500 errors.
I think we were.
So you want to do filter by 500?
Sure, yeah.
So up here in this box, you can chain together these filters. So if they're the same, then it ORs them. If they're different, it ANDs them. So kind of intuitive. And so we'll look at the 500 requests, and it looks like we're getting quite a few of those. And you can see as she's scrolling, there are new ones coming in. So let's drill into one of those and see if we can kind of debug this problem right here in front of all these people.
Okay, so it looks like we have a backtrace here. Backtrace an exception raised at line 48, apparently. Let's compare that to another one as well. Oh, yeah, it looks very similar.
Yeah, looks like we have that problem. So at this point, we've done some investigation. We've got a stack trace. That's pretty good. But as a developer, the next thing I want to do is jump into some code. Like I need to actually see the code that was deployed, compare that to the results I'm seeing to be able to figure out how to fix this problem. But we have to find the source code. We have to get the right version of the source code. We have to get the right file and the right line number. But you know, Mandy, I noticed that's a hyperlink there.
Well, these ones, yeah, they look quite interesting.
Yeah, it's quite interesting. There's a hyperlink. Why don't we just click on that hyperlink and see what happens? So notice that this brings
us least surprise.
Yeah, exactly. So this brings us back into that source code viewer at exactly the file and line number that caused the problem. So we are actually connecting the logs at runtime to your development time experience. So while you have all that knowledge in your head as a developer about the issue, you're ready to look at code and actually solve that issue right now and get your production issue taken care of.
I kind of remember reviewing this CL.
Yeah.
This is your code, wasn't it?
It might have been, but you LGTM'd it. So
yeah, that's pretty bad of me.
So at this point, Mandy could go do a change on her local machine. She could use Open in IDE and make a change. Or because I think the fix is kind of obvious here, Mandy can just click Edit right here in the browser.
All right, let's do that.
And if she clicks Edit in the browser, then she can take care of this issue right now while it's fresh in our minds. We can get this taken care of. And then go ahead and commit it back. So why don't you go ahead and commit it when you're done with that. Yeah. So she's going to commit it back. So how many of you have debugged a production issue and actually SSH'd into a production machine and changed some PHP code or a config file or something? How many people have done that? Yeah, that's not such a good practice. And that's not what we're doing here, right? I want to emphasize what we're doing here. I think she'll see in a second. What we're doing here is we're actually committing this back to our Git repository. That change is attributed to Mandy now, and she's given a comment for why that happened. The change is committed to the production Git repository. So all future deployments we do will have that change. You won't have this issue of a regression. We're also running a build and unit tests over across that change to be sure we're not actually making the situation worse in the panic to fix this issue. And all that is happening in real time. I guess it's not quite there yet. So the line gets added as soon as the GCE VM gets the source code, and that takes just a second for that sync to happen. Once we run all those unit tests, then we have, what is it, about 20, how many instances?
We had 20 instances running. So.
Yeah, so we have about 20 instances running. Then we have to go update all 20 of those live production instances with the new code. So 22 instances running. So we have to drain the traffic that's on the existing instances and bring them up on new instances running a new version of the application. And all that has happened, basically. It has all happened.
And there's the diff from the code change that we just made. And you can see we commented out the code now. So
assuming we're correct in that change happened, we should be able to go back to the logs now and see if we keep seeing those 500s. So let's see if there's any 500s. Look at that.
That's good.
That's pretty good. No 500s. So it's a nice clean logs, exactly what we'd expect. Mandy's skeptical, so she wants to actually query for the 500s.
I love this spinning beach ball. It's mesmerizing.
And again, this is aggregating over lots of logs. We're gathering those logs in real time from all the 22 instances that are there and filtering on those and having some network issues, it seems like. Okay, should we just trust it?
I think we should just try once more, just in case.
Okay, so we see the old 500s. The oldest timestamp was from 8:52.
So again, we switch back. So we need to fix that.
We definitely need to fix that.
We need to make sure that stays in your local time zone. It starts off in your local time zone and then stays there. So looking at that again, spinning the beach floor again.
Jeez, yes.
So in the meantime, I think we saw anyway that there were no new errors.
Yes.
So we can basically, I want to wait for this to finish.
Okay. You're driving.
I know.
So any questions so far about what you saw while we wait? Anyone? Yeah.
Is this latest version which has a GitHub integration? I haven't seen it on my developer console.
Yes. If you notice the URL here, cloud event, this is actually on our a staging instance. So it's not everything you're seeing is not quite ready. Sarah is actively working on that right now, getting all this pushed to production. But it'll all be there in the next couple of months or so. So it's all coming very soon.
In the
Next
next week.
week?
Well, pieces of it.
Oh, okay, okay.
So kind of wrap
So
this up.
soon, and we'll give you, if you just can't wait, we'll give you a URL at the end and you can get access to this machine.
And to kind of wrap this up, it's 4:55 now, and the last error was at 16:52. So that's good.
Awesome, so we got it. Okay, cool, so we want to switch back to slides. Okay, so what we showed you was some simple load testing. We did debugging production. We fixed that issue. There's a whole talk, a 30-minute talk just on that. If you want to grab that code, you can get access to that on YouTube.
And somebody did ask yesterday about whether you can pull from the repository, and at this point, because we have a unique change within the repo, we could actually synchronize locally to our local instance, our local repo by doing git pull. So.
Okay, so I hope what you saw is that we started from scratch. We created a brand application that was real. It had an Android app, MongoDB backend, and we showed you some basic DevOps scenarios with deploying at scale. Okay, so the source code for the actual meme generation app, if you want to launch your next startup, that's a meme generator, you can go do that. All that's available at that GitHub URL. Somebody asked, set up pretty nicely here, can they get access to this? A lot of what we showed you, the logs viewer, the console, the Git repo and everything is available already. The GitHub support, the code editing, some of the source diffing is rolling out over the next few weeks. But if you just can't stand it, you can go to that Trusted Tester sign up and get that. We thank you for this part. Thank you very much.